The last thing that we need to talk about is acid rain. So we just looked at the fact that we have all sorts of different acidic or basic aqueous solutions. So what happens with rain? So normal rain is actually slightly acidic, but rain that has a pH of less than 5.3 is considered to be acid rain. When we look at acid rain, you can see some areas that have some average values here in North America. Now, what's interesting is when you start to really look at acid rain, there's a lot of different things that will cause acid rain. A lot of them are absolutely 100% human caused, but they're not all human caused. There's actually areas that aren't infiltrated by humans so much that we see more acidity than we would have expected to, because it's not just things that humans do that can acidify rain. So different things that will cause acid rain are sulfur oxide compounds, are nitrogen oxide compounds, and carbon dioxide. So we can get acidic rain in areas where there's a decent amount of carbon dioxide emissions. So if there's a lot of plant or animal life that gives off a lot of carbon dioxide, it can actually acidify the rain more than you would expect it to. Now, not all rain in areas with heavy plant and animal life is going to be acid rain, but it may have a slightly higher acidity than you would have expected in an area without a lot of human interaction. The sulfur oxide emissions, when volcanoes erupt, volcanoes spew a lot of sulfur into the air. And so a volcanic eruption can cause quite a bit of acid rain issue as well. And obviously, humans don't cause volcanoes to erupt. That's a natural phenomenon. So that can cause acid rain. Most of the places where we see acid rain are indeed human caused, but it's not just human caused things that can cause rain to be acidic or more acidic than you would expect. Okay, so what this implies is where we have heavy producers of sulfur and nitrogen oxides are where we should see the most, acid rain. When we've got a lot of areas with coal-fired electrical plants, steel mills, other places that use a lot of coal, we get a lot of those sulfur dioxide emissions. And then our nitrogen oxide emissions, we've got large urban areas, lots of population density, lots of automobile traffic. Our cars do put a lot of this stuff into the air. So what happens to make these things acidic? So things like sulfur trioxide reacts with water and we get sulfuric acid. Our nitrogen dioxide reacts with water and oxygen and we get nitric acid. Carbon dioxide reacts with water and we get carbonic acid. And so these things up in the air, because what do we know about, well, rain obviously is water, and also as rain is forming, we've got all this moisture in the air, and so this stuff, when it gets into the air, reacts with the moisture in the air, acidifies that, and then when it rains, if it's there at a great enough concentration, then yes, we will get what is considered acid rain. So we can get wet deposition, we can get dry deposition from our atmosphere containing higher than average amounts of these compounds. Because again, it's not just human areas that are going to give off this stuff. We do get some of this stuff done naturally, which is why rain is slightly on the acidic side, no matter where you find it. Okay. Coal combustion, that's where we get our sulfur dioxide. Ontario, we get a lot of that sulfur in the air, so that one produces tons of that sulfur dioxide. Our nitrogen oxides, we've seen big problems with this in LA. So some people have called this the LA acid. I actually don't really see that so much anymore, but I have seen it refer to that in the past. So where do we get that from? Transportation. Where do we have a high car density? In very urban areas like LA. And so there have been times when LA has had like terrible problems with smog and acid rain. So we've worked really hard to combat this. It's why California has some of the strictest automobile emissions in the entire United States. It may seem like it's a pain, especially these days, especially if you're younger and you don't remember any of this stuff. So I barely remember this. So I was born in 1981. So this January 1982, I was not even a year old. December 1982, I was just over a year old when we had these issues in LA throwing pHs of 2.5 or 1.5. I do remember growing up, LA was very, very smoggy. It was not a pleasant place to drive. You could get there a lot faster then than you can today, but it wasn't a place a lot of people wanted to drive because of all of these issues, and it was so smoggy. Even here in San Diego. So we've looked at smog before in this course, and we know that when we have like a valley basin, and LA exists in a valley basin, and so it traps that. El Cajon here in San Diego, this is a place where this gets trapped as well because of the mountains that surround El Cajon. I can remember growing up driving into El Cajon, and as soon as you come around the 8 and get into that El Cajon area, just seeing the brown smoggy gunk in El Cajon because of where it trapped that. It's a lot better now. I still see that every once in a while, but it used to be pretty much a guaranteed thing when I was much younger driving into El Cajon. It's not guaranteed anymore, and that's because we have worked really hard to combat these problems because we know that they're huge problems now. Okay. Now, when we don't have automobiles, we get these nitrogen oxides from aircraft engines as well. So our planes aren't emission free when they fly. Okay. And so we get lots of different emissions of these sulfur dioxides and these nitrogen oxide compounds. And so we can look at natural emissions, so natural oceans, soil, volcanoes, lightning, all right? You can see the soil and plants, they give off a lot of those nitrogen oxides. And then when we burn things, we give off a lot of these compounds. Now, when we look at what acid rain does, you can see things like this. So this is marble statue. So what's interesting is that carbonic acid that I mentioned. So carbonic acid will form, but carbonic acid is not stable. So carbonic acid will decompose pretty readily into carbon dioxide and liquid water. So marble is a rock that has a carbonate anion in it. So if I have acidic rain, I have a proton, all right? So I have a proton, all right? So that's my acid rain. Okay, so this is all right, so if I have this from acid rain, okay, there's my carbonate anion. Okay, what I get is carbon dioxide and water. And so if it's raining and I'm forming carbon dioxide and water, the carbon dioxide's fizzing off and the water's washing away. And so we can actually dissolve marble with acid. So if I have just regular old distilled water and I pour it on a marble, it's not going to do anything. But if I take acid and I drop that on the marble, it will start to fizz. That's the carbon dioxide coming off. And then you'll see some liquid pooling, and that's the water that has been formed, as well as the water that the acid was already dissolved into. And so we can degrade down these marble statues if we have acid rain. And depending on how acidic the rain is how fast these will degrade down. So here's another illustration. So here's what a statue looked like in 1944 and what this looks like more present. So you can see that degradation there is from reaction with acid. Okay, your cars also suffer from acid rain. So when you have a car, you've got your body panel, and then there's a substrate primer that's put on it, and then the color of your car is done by this base coat, and then there's a clear coat that's put on top of it, and that clear coat is pretty thick because the clear coat has to protect your paint job and the car itself, because if you get all the way down through the paint and you get down to that body panel, you get down to the metal, and then stuff can get in and it can start reacting with the metal, which is where you see cars starting to rust away. So things can damage your clear coat. Stains, things can oxidize, stuff can scratch it, and acidic stuff will etch down your clear coat. So if you've ever owned a car and had to get the car repainted, they will tell you not to park under a tree for a certain amount of time because the clear coat takes a much longer time to cure than they can keep your car. So they release your car to you when the clear coat is usable enough after like a day or two. But it doesn't cure for a few weeks, so it's even less protective, and so stuff will eat away at it really fast. Bird poop. So if you're under a tree, you're more likely to get bird poop. Bird poop is really acidic, and so if you get bird poop on a freshly painted car, it's going to eat that clear coat so fast. And acid rain will eventually eat down your clear coat as well and not protect your car from all the other things in the element. So metals get corroded by acids, so you can see that in areas. We get some protection from rust and acid rain, but if we eat away at these paints and coatings, then we lose that protection. We can do some things that we can actually do this cathodic or anodic protection where we put something on metal, and so they do this on bridges where that area will get eaten away first. That will protect from rust, but it doesn't really protect from acid rain. So we can plate stuff, but that gets eaten away, and once the plating or the coating gets eaten away, then we have to replace it. Sometimes if the air quality, the water quality is really bad, if we have all this stuff in there, we can actually reduce our visibility due to all those particles in the air. We see this with fog. So fog is perfectly normal, but fog reduces our visibility because we have all these aerosol particles in the air. Okay? Acid rain is bad. We don't want to intake acid like that into ourselves. Yeah, so you want to be careful around inhaling in acids and the fact that we can cause these things to be dissolved, and that can end up in our water as well, because we don't want to drink heavy metals. And so if acid rain reacts with things and then that dissolves and then that runs off, it can get into our water supply and can cause health effects that way.